I know we're next to the last session, so thanks for coming and sticking around for this. My name is Mark Tremashot. I run technical business development for storage services for AWS. In other words, I help out. I'm an extension of the storage team out working with customers like yourself. So feel free to, we're going to save questions probably till the end, but I'm happy to have some conversations afterwards. We also have some engineering leads and product managers here as well for Q&A if you like. So how many of you are familiar or are using S3 today? You just get a little sense. Okay, good. I always like to tailor the content. So I'm going to give a little bit of an overview on S3, and then the title is Deep Dive on S3. What I'm going to go through are a number of different areas, including performance management and some security considerations, as well as new capabilities and tools we have not only in S3, but also in our entire object storage portfolio, including Glacier. So for the 20% of you that didn't raise your hands, I'm going to spend a minute or so on AWS storage. So hopefully over the last couple days you've heard a little bit about the AWS compute and the entire family of 70+ services that we offer. But I wanted to do a little deeper dive on the different storage offerings. So for those of you that are familiar with more enterprise traditional storage solutions like SAN and NAS, we also have block storage, that's EBS, or directly attached to EC2, we have instance stores. For those of you that are familiar with NAS or have NAS, we have EFS. How many of you are using EFS today? Okay, probably a smaller amount. So this is our managed NAS. We launched it last year, NFS 4.1, and really it's great for any type of application that needs a POSIX-compliant file system, right? So you think if you have multiple EC2 instances, multiple compute instances sharing common data sets, that's exactly what EFS was designed for. Also, a lot of customers that I talk to have maybe older applications. They want to port their, and they don't want to have to re-architect them, say for an object store. This allows you to easily lift and shift those applications and take advantage of a file system-based solution, which is EFS. So those are kind of the traditional block and file equivalents from enterprise. Today, the session, I wanted to focus mostly on our object stores. So we have S3. I think everybody's familiar with that. Anybody shout out? There's one bullet missing here. What goes between S3 and Glacier? SIA, right, S3 infrequent access. So S3 really has two pieces. We have a top tier called S3. It's been around, actually we just celebrated our 11-year anniversary. And S3 infrequent access, which we introduced in 2015 for less frequently used data. And then finally for the colder data, that's why with the name Glacier, we have Glacier. So those are the object storage components. And then one of the big things that we talk about is data has gravity. It takes a lot to get in. Once data gets there, it's hard to move it out. So seismic data, obviously, but genomics data, videos increasingly, right? They're going from high def to 4K to 8K. There's a lot of density. And so what we're seeing in general is it takes a long time to move data from point A to point B. And we've been working with a lot of customers. You might have heard Digital Globe. They've spoken about moving petabytes, 50 petabytes of data plus. FINRA, who's moving a lot of data lake data in. That data takes a lot to move over traditional wire, right? So we have working with customers to move that data in, and we'll go through a few of those solutions to expedite that move, either continuously, meaning in an online mode, or via a batch mode, at one at a time. So Snowball is an example of batch. Snowmobile is an example of a big batch, and things like Storage Gateway and transfer acceleration are examples of more of that real time where you want to maintain that connectivity. So basically today, if you get, hopefully, it's usually if you get 1 out of 5, I feel it's a good session, right? So one of these, hopefully you'll be able to, depending on how much experience you have with AWS, you'll take at least one of these 5 bullets away and 1 nugget away from the session. So first of all, we want to make sure that you understand the different storage classes. A lot of times there's some misnomers. We're also continuously innovating, so there are some nuances of the different storage tiers that we want to get into. Hopefully even if you're using S3 today, maybe you'll think about using S3 infrequent access or even Glacier. Automation, we've added a lot. So I joined AWS a few years ago, and one of the things that was awesome was just S3 just worked, right? But it was also a black box, right? So what we heard from customers a lot was more visibility, more automation, more optimization into really helping them in their workloads and workflows and lifecycle management. So automation and optimization were things that we really focused on, and we had a number of things that we introduced at last reInvent to address those. Management as well, and it goes with visibility. And then finally, migration, tiering, and bursting, moving data in and out. Uh-oh, I broke it. Damn. Here, hang on. Can we, It was all going so well. Yes! Thank you. Thank you. 3 buttons, push the right one, we'll get it set. So first of all, we have S3 standard. That's for our active use case data. We have standard infrequent access, and that's for our infrequently accessed data. And then we have Glacier. And really, as you go down the curve, there are really 3 different use cases that you can think about. And we've mapped some of the both commercial as well as public sector customers and use cases. So S3 standard is the one that's been around for a while. You can think about that as fairly hot data that you're going to access regularly in what we call US major regions, and also in Dublin and Europe, a little bit different in GovCloud. That's priced at about 2.3 cents per gig per month. And with that, basically, you can access all you want. You can access and all the data. So if you think about it, you have big data analysis where you're touching the data quite a bit. You're doing content distribution like streaming data, like Netflix. You're doing static website hosting. So anytime that a good percentage of the data is touched on a regular basis, S3 is the perfect, very highly durable, highly stable platform for that. When you think about, though, many other types of data don't fall into that type of data set because only a small percentage of data might be accessed on a particular month. It doesn't matter what data, but if you say you have a petabyte of data, and on any given month, maybe only 10% of that data, it might be 10%, 10% one month, another 10% a second month, a third 10%, maybe another month 15%. That's when you want to start considering S3 infrequent access. So you say, well, I'm still accessing data, and I got like maybe 10 files that are super hot. Well, but step back a little bit and look at the overall data set and say, is it 5%, 10%, 20%? Anything under even almost 100%, you're going to benefit from savings from S3 infrequent access, or SIA, because SIA is priced at 1.25 cents per gig per month. So a little bit over half of what S3 is. But every retrieval, every time you touch a file or an object and pull it out, we charge you a penny per gig for retrieval. So if you do the math really quickly, you can see that if you access 100% of your petabyte every month, it'd be 1.25 cents plus 1 gig, or 1 cent per gig. So it'd be 2.25 cents per month if you access 100% of the data. So you can actually break even at about 100% access. So again, it's a tier that we introduced that I think has maybe a little less knowledge, but it's a great tier for backup and archive, DR, file sync and share, and any longer retained data. Pinterest is a good example. They have a lot of images. They're accessed very frequently, and then very quickly they're not that interesting anymore, and they move down the stack, and they're touched less frequently. Huddle is another customer of ours that has videos. So anybody doing video data, it's really hot for a period of time, and maybe after a few weeks, then it basically goes much colder and is less frequently accessed. So anything with a life cycle of that, consider S3 infrequent access. Now, there's a demarcation within Glacier. So if you need data, and you need data synchronously or in milliseconds, right, then either S3 or S3 infrequent access are the ones that you want to go with. However, if you want and you can tolerate just a little bit more time, minutes to hours, you can get a lot of additional cost savings with Amazon Glacier. So you can think about Illumina, who uses us for genome sequencing, long-term genome data. Sony DADC actually reinvented their entire workflow. They went from, they basically say you want the newest Spider-Man movie, and you're an Indian broadcaster. You say, I want 10 different bit rates of the newest Spider-Man movie. What they used to do is go to their tape library, pull it out, take 5 days to transcode transcode it into the 20 different formats that Indian broadcaster wanted, and then ship it out either on a disk or something using Aspera, for example, which is a data transfer protocol for broadcasters out to that Indian broadcaster. Today, they've compressed that 5 days to 24 minutes. The original target was 1 hour. And they store all of those large assets on Glacier, and then the transcoded assets, they basically pull those large assets out, transcode those on the S3 and frequent access, and then distribute them out. So again, you can think about these things complementing one another. Glacier is 4 cents per, or 0.4 of a cent per gig. So one third of the cost of standard infrequent access. So you get a lot of cost savings there, and a penny per gig for retrieval. And we'll talk about some other options there as well. So one thing underlying all of this is when you're thinking about traditional enterprise storage and comparing it to traditional enterprise storage, I have a long history of storage, and I always think about the traditional enterprise storage backup and number of copies and DR scenarios. And typically you have maybe a primary site, you have tape backups, you also then maybe replicate that data. Some of the data is replicated synchronously, some of it's asynchronously to another site, right? So these are pretty common scenarios for traditional enterprise. Well, and so when you think about it, when you're storing a gig, a petabyte, an exabyte of data, with a traditional enterprise storage, you're storing it once, maybe making another copy of it, maybe making a third copy of it, and then maybe still making a backup of it, so you're storing it many times. And so one thing that underlies all of our storage is this notion of durability. And one of the things that we talk about is 11 nines of durability. And what the heck is 11 nines of durability? So I wanted to kind of drill in that just a second and talk about what 11 nines of durability is. So if you think we worked with a consulting firm, and a consulting firm worked with a lot of media companies who have long-term preservation requirements. And what these media companies do are one of two things. They either make 2 copies, so they have a new video, they make 2 copies of that, so that's 2 tapes. Or they might have a primary site, make a copy, and then move it over to a second site and make another copy. Those, when you look at durability, and durability is the mathematical probability that an object will be lost or corrupted in some way. The first scenario has 4 nines of durability. The second scenario has about 5 nines of durability when you do the mathematical computation of that possibility happening. We have 11 nines, which means that we're 6 to 7 orders of magnitude less likely to lose. In fact, it's billions of years would have to go by to lose an object is the math, and it's actually, there's a little analysis on our website about exactly the formula that we used. So that's the durability aspect. Under the covers as well, the other thing that you get is when we think about durability, it's multi-site durability. So every single object, anything that we write, is stored across a minimum of 3 different availability zones, 3 different physical data centers. So even if you, say, have a power cut, or a more likely a connection cut, or a flood, or a whole facility goes away, basically the data can still be accessed and reconstructed from the remaining 2 facilities. So durability is a lot more than making copies. When you're storing 1 gigabyte of data, what you're getting is essentially many copies of that data and a very highly durable version of that. Make sense? So, okay, great. So one of the things we talk about S3IA versus S3. So we talked about it. When do you use it? When to move to it? For all of 2016, I spent a lot of time, we introduced S3 and frequent access, and we talked to customers. And they said, hey, I've got all this data on S3, and I don't know what's hot and what's not. So hot, not. And so we had some customers who were very advanced and adventurous. They took the log files from S3, ran them through an EMR job, and then took basically the output of that EMR job and did an analysis to move the data manually through and into S3 infrequent access. Why? Because half the cost, right? So what we introduced, so that I had to go through this process a lot less with customers, was a one-button tool called S3 Storage Analytics Storage Class Analysis. And so this allows you to essentially automate a lot what I talked about what customers were doing with their EMR jobs before, which is scan through, push the button, have it scan through for 30 days, and then make up recommendations on how much and how often the data should be tiered. So Amazon Glacier, so that was S3. Amazon Glacier is the lowest, coldest tier. It's optimized for that very infrequent retrieval. It's even lower cost, has the same durability that we talked about as S3 and S3 and frequent access. A lot of customers, in fact, even here today, I've had a lot of EBCs, customers moving off tape, say traditionally, or a combination of disk and tape, have looked at Amazon Glacier, especially for that long-term, highly durable retrieval requirement. The additional thing, especially for public sector customers, you can think about, we have a feature within Glacier called Vault Lock. Vault Lock passes the SEC 17A4 and other requirements for compliance. Essentially, this provides a layer of retention option. So you can, if your retention is 1 year, 2 years, 7 years, 10 years, and in healthcare, for example, it's 7 years, 21 years, depending on age of patient. And I know that different industries and different organizations, some are just forever and retain forever. We can do that as well. So that's what Vault Lock does, is allow you, in addition to storing the data and making sure that it doesn't get changed, we can also put a retention period on it to keep it for any number of months, years, and not allow any deletion of that data for that period of time. So the cool new thing that we introduced at the end of last year was when we worked with a lot of customers, they said, it's S3 and frequent access is great, and Glacier is great, but Glacier typically takes 3 to 5 hours to get data back. So I really need it. I don't need it in milliseconds. I have, say, an archive. I'm using a tape system, and I have images or I have documents, but I need to retrieve maybe gigabytes, terabytes, or petabytes of data within hours. And then a few of them, though, and we were talking a lot to broadcasters and media companies, but some of you have this requirement as well, said, that's the majority of it, but I really would like to get a couple in minutes. Under 5 minutes, actually, would be awesome. So we introduced expedited retrieval. So that allows you to store it in Glacier, so super low cost, so still cost 0.4 cents per gig, but you can retrieve it, and we will retrieve then those files in 1 to 5 minutes. So it allows you now when you need that emergency access. And we have a couple customers that we're actually responding to RFIs and RFPs on now in public sector where they're only using expedited retrieval as the primary. So it's, again, I think we looked at it as quote unquote emergency, but if you look at it and look at the economics and balance it out, in many use cases, it could also be, they could be the primary type of retrieval that you might use depending on your use case. The opposite is, we also had customers that said, I want to rip through, 100 petabytes of data, and I want to do large-scale analysis, or I want to do machine learning, or I want to transcode in the broadcast industry from one bit rate into something else. So we, at the same time that we introduced expedited, super fast, we introduced super slow bulk retrieval option, which basically allows you to get your data back in 5 to 12 hours. Well, why would you want to do that? It's a lot cheaper. So it's a quarter of a cent per gig. So you can retrieve an entire petabyte for a little bit over $2,000. So again, we're trying to match essentially what your SLA is for retrieval and retrieval requirements to your cost with these different solutions. Make sense? Okay, cool. So FINRA, I think you've seen them before. So they're a great example of pulling all of this together in a great use case using us for a data lake. So a data lake, for those of you that aren't familiar with the term, so data lake is essentially taking all of your different silos, if you will, of data that might be stored in a number of different, if you will, silos of Hadoop clusters, existing on-premise, might be new data coming in, log files, different types of just raw data. And when you run it on-prem, and this is what FINRA was running, was kind of on-prem, they had a number of different silos. They were actually analyzing about 75 billion events per day, and they moved that entire solution over from their on-premise into AWS. And the benefit at a real high level, and we can dive into the weeds, this is not a big data and data lake a deep dive session, but the takeaway is when you have multiple silos of data and multiple analytics tools accessing that data, what happens? Well, Hadoop, first of all, you have to make 3 copies of each, and if you have multiple Hadoop clusters, you actually might get a multiplier effect of having that data then multiplied and multiplied and multiplied again, multiple data sets. So when you move that and consolidate that into a single lake of data, immediately you get the benefit of a lower cost of storage because you reduce it by a factor of 3 or more. The other is just efficiency of being able to share that data. So typically in on-premise big data and analytics environments, you have, say, a tool accessing a data set. With AWS, what you can do is spin up, say, an EMR instance or any other analytics services, store that in S3, pull it out of S3, stick it in and actually use the data and analytics tools, and that might be, say, in an EBS instance or EMR or Redshift, depending on what your particular use case is, process the data, and then dump it back out to S3. And that's a very typical way, the customers ensure basically the low cost and high durability and using that for S3, but then use that, if you will, analytics on demand shared across multiple analytics instances and application types. So again, real simple consolidation and then sharing are the real things, but then scale, right? So those are kind of the real takeaways, and there's a whole case study we'd be happy to share with you on FINRA and the efficiencies. And we have a lot of customers now looking at doing exactly that, either A, building a data lake from scratch. We have log files, for example, is a great example where customers are beginning to do that, or migrating existing on-premise siloed analytics cases. So that's a data lake example, and that's one of the applications that you can run, and one of the big growth areas that we see for S3 and frequent access, and even Glacier, because you can take the results of that analytics and dump it down to Glacier, for example, and keep that for long term at a very low cost and at a highly durable tier as well. Digital Globe, we have Jay Littlepage, I think, has been speaking here. He's been just a great partner, and Digital Globe's been a great partner. They reinvented their business. So a lot of this is about also digital transformation. So similar to Sony, which is in media, Digital Globe obviously shoots a lot of satellites up in the sky, takes a lot of images, and very actually interesting, similar analogy to Sony, instead of movie or broadcasters being the requesters or customers, they have other government organizations, both domestic and international, that are their customers, as well as some commercial organizations. So they might have, for example, somebody in France might request, hey, I want to see what what happened to ozone depletion over Paris over the last 20 years and get a time series analysis of that. So they'll put that request into Digital Globe, and what they used to do is go to their tapes, maybe go to offsite, have somebody in 5 to 10 days later package it up, stick it on a hard drive, ship it to France. What they did is automate that whole thing, moved 50 petabytes of their image library into AWS with a snowmobile, and they've automated that entire workflow. So now, and the expression that Jay Littlepage and the team there at Digital Globe talked about was taking that data off of tape allowed them to free their imprisoned digital assets. They use this term imprisoned. And if you really think about it, whether the further it is away, especially if it's offsite in a salt mine somewhere, there's a high friction level of getting that data back and actually using it. Certainly it's possible to do it, but the friction's high. As you move that and make it instantly available, all of a sudden new workloads and new use cases can become available. So now there's all kinds of new things that Digital Globe is thinking about in terms of the workflow, in terms of different types of partnering, distribution of that data now that it's constantly and instantly available. So keep that in your minds. It's not just about the pure cost savings up front, and certainly there was that versus tape and so on, and efficiencies in getting the data, but it's also about digital transformation, thinking about transforming as you're migrating the data. I have a lot of conversations with customers. Don't just think about taking what you have and moving it, but also what new use cases might come out of it as you move it into the cloud. So those are the right storage classes and examples. So one thing we wanted to do now is manage the data. So I think I talked earlier, one of the new capabilities was basically the ability to look at the heat map. So this is a good example of S3 customer data and how much of the data is being accessed in any particular month. And so you see kind of on the left to the right, you have, and because my eyes are small, or my eyes are bad, I have to look on the screen here. You have October 30th to about end of November, again, a time series analysis of how much data. And you can see the data retrieved as a percentage of the total storage, right? And you can see data retrieved was 2 petabytes and 3 petabytes their total size. So based on this, we then can run an analysis, and usually we recommend about a 30-day analysis, and it generates a heat map. And we have a solution called lifecycle management that says, great, after X amount of days, move the data from S3 to S3 infrequent access. After Y amount of days, then you can move that from S3 infrequent access into Glacier, or you could say after Y amount of days, purge the data, delete it, say if it's just scratch data. And what this tool, which is S3 Analytics, allows you to do is automate that. So it comes up as think about it as a recommendation engine for your lifecycle management. So in this case, we took a look and we said how much of the data is infrequently accessed, analyzed over the past 120 days. You can certainly see that a lot of it was accessed within 30, 45, and so on, but then it's a huge drop-off between 90 to 180 days, right? So, there, we come up with a recommendation of what lifecycle policy to set. Now, you can use our tool, but the cool thing is also, especially if you have large amounts of objects, you can export this into any of our tools or any third-party analytics tools. Excel's a real popular choice. Pivot tables, I love them. I think many people do, so we support that. You can export it into really any format, including our own QuickSight, but also third-party tools that are out there for those analytics. So once you have this data, now you can plug it into what we call data lifecycle management, which is another advanced capability that we have. So data lifecycle management allows you to set policies to move data from S3 to S3 infrequent access, and then to Glacier. And you can set this by a number of days from object creation date. You can also match on different types of attributes. So you can match by bucket. So a fundamental concept of S3 is this bucket of data, of objects. So you can say this object policy applies to this entire bucket or category. You can do a prefix, meaning any object or file name that starts with X, apply this policy to. So you can say everything that is, DOD is this, anything that is ABC is this, anything that is, FBI is this, and with prefix, and have different policies based on that. The third thing, and I haven't talked about it yet, but we have a new capability called tagging. And so you can also take lifecycle management and create a tag, a object level tag that is a new capability, and I'll talk about that in a minute, to say, okay, great, all of this data set is, say, used highly by a certain department, so we want to keep it on S3 forever. But this one, we know that it's used for like 10 days, and so this other department, you want to be able to move it down very quickly to S3 infrequent access, or even delete it after 30 days. So based on tags or any of these other attributes, you can set these lifecycle policies. So the way that you do that is very simple. You can do it programmatically, or you can do it through the console. So here we show an example, put in and call it a rule, and basically say by prefix, we're going to basically, and then by a tag, and you can enter it there. You can say, take the current version. We also offer something called versioning, and we'll talk about that. So if you turn on versioning within our solution, basically, and you delete an object, you say, whoops, what do you do? We actually can retrieve that previous version. So think about it as a recycle bin. But you can actually, with lifecycle, either have just for this version or for previous versions as well. And then you simply say and walk through it and say, object was created after X days, move it to S3 infrequent access, so in this case 90 days, and then after 1 year, move it to Glacier. So really, really simple to use the lifecycle management within AWS S3 to get those cost efficiencies. And then you can also configure expiration. So one of the things that's not necessarily logical is, I think about lifecycle management as just tiering, but another example of lifecycle management is also deletion or purging or expiration of that data. So in this case, we can say that 10 years after object creation, we can delete the current version as well as the previous versions of the objects. And that's this use case. Again, very simple, very straightforward to do this either via CLI or via the console. So speaking of versioning, versioning protects users, deletes, or application logic failures. So, obviously, if people think, well, a lot about deletion and malicious deletion, but the reality is we have a lot of, where, whoops, this application accidentally deleted, 5,000, or we had one case, like 1 million objects, right? Luckily, that customer had versioning turned on, because what they can do is basically, when you delete that, you can say, go back to the previous version, and we were able to restore, or they were able to restore, those previous versions of those objects. So it's a real good kind of, prevention mechanism for accidental or malicious. If you never delete anything, it doesn't cost you anything. So best practice, we always recommend that you turn it on. If you delete and you want to keep multiple versions and everything, certainly there's a cost to store each object. But again, if your application doesn't intentionally and there's no kind of deletion mechanism or certain buckets aren't designed to do that, then great, basically, way to prevent fat fingers, right? So, or from either an application or malicious or non-malicious user. So that's one big tip, is turn on versioning always, if you can, to prevent accidental deletion. That prevents a lot of egg on the face and a lot of maybe calls to support. So another best practice are event notifications. So this is pretty common. We introduced and expanded last year event notifications. So what we can do is whenever you put, so in S3 parlance, putting is writing, and deleting is something else, is deleting. So, and anytime that you basically put or any of these actions are conducted with S3, we trigger an event notification. So what does that mean? Well, we can do cool things. So for example, when something is put in, the most common use case out there is you put an image up. Basically, it'll trigger a Lambda. Everybody know Lambda and a serverless compute? So basically, it's you don't have to stand up an EC2 instance. You basically trigger compute on demand, run a function, and it goes away. So it's like, this ethereal compute, serverless computing, and we can trigger a Lambda function to do, for example, a transcode. So very, very typical use case, drop in a photo and transcode it to a thumbnail. Or take a video and transcode that to a lower bitrate version. You can also do things like trigger messaging, so get notifications whenever certain objects have been updated. That can trigger an SQS or SNS message. So again, Lambda, very, very powerful because you can build a whole library of functions around it, and that can be triggered via these events automatically rather than writing a whole process around it and standing it up in EC2. So another best practice is cross-region replication. So many customers have a requirement where either for compliance, I used to work a lot with some of the agencies, and they want to make sure that they have data just from a compliance reason. You're mandated to keep it both on the East Coast and the West Coast, right? So for compliance. Oftentimes, though, more I see, the application, either users or owners of the application itself, requires lower latency access to that data. So in these cases, what you want to be able to do is perhaps move all or part of that data from one region, AWS region, to another. And so we have something called cross-region replication. You can just turn it on any bucket, and basically you can replicate the data from that region to another region in the background automatically, cross-region replication. So you can do the entire bucket, you can do it on a prefix, and it's a one-to-one replication between any two regions. So what's there? We also have some new capabilities that are coming out that are going to be enhancing this cross-region replication. We'd be happy to talk to you about those after the session. So these are that category now if you think about automating management tools. So versus just black box and just storage and having you do the heavy lift, we have a number of solutions that just make it easier to automate your management tasks. So whether it's copying data from one region to another, the lifecycle policy, the event, rather than you having to do that and stand up instances, and then also with versioning, obviously easily recover from accidental deletions. So what I hear a lot from customers is now, and I know a lot of you are using S3, and some of you might be power users, right? So that's where this next section comes in, is performance. So performance and management kind of go hand in hand. So one of the first things we talk about is to get data in. We talk about data having gravity. So how do you get data in faster? So we're going to talk about a couple other ways to get data in faster in a little bit. But one of the S3 primary capabilities from an S3 platform standpoint is something called multipart upload. So I used to work in networking and WAN optimization. And so the analogy for any of you that are network propeller heads is, right, do you ever want to open up one flow over a highly latent link, right? What happens? It goes really slow, right? Especially as you increase latency, even if you've got a really fat pipe. So if you think about it, likewise here, S3 is this massively parallel system where we have many, many compute front-ended by storage on the back end. But if you're uploading one object or one file, it's only going to basically hit that one front-end node. And therefore, you're not going to take advantage of the parallelization of the system, of the massive scale. So big tip is if you're not using it today, and a lot of the SDKs just incorporate this, please use multi-part upload, especially for larger objects. We'll chunk it up, and then we'll basically upload those objects as multiple parts in parallel. The other benefit is that it's going to go over the wire. It'll be able to, especially for highly latent links, you're then going to be able to saturate that wire or your bandwidth a lot more than if you just upload one large file. Again, you won't get all the efficiencies, especially for those higher latent links. So upload, and it goes up, comes down, right? So probably this is more common for you. Is you're probably only going to do the uploads every once in a while. In many use cases, it's 98% down and 1% up. But you can also get faster downloads by using, again, parallelization. Parallelization is your friend. I have to repeat that because you could say parallelization, that would be paralyzing, but parallelization is your friend. But again, you can now parallelize your gets as well as the puts. And the way that you do that, you use something called range gets. So that allows you to get pieces of an object. And you can set up, say, if you're doing it with EC2, you can say spin up multiple EC2 instances, set up multiple threads, and basically each one of those then can grab a part of the object. And again, you're parallelizing that retrieval, so that provides much faster throughput. Again, versus the pig through the snake scenario where you have a big object and you're trying to squeeze it through one. This allows you to spread it out across. Also, big tip is use CloudFront because if you've accessed it, especially if you're accessing it out of AWS, we cache the objects at the edge, so therefore the user doesn't have to go all the way back to S3 to just access it. It also saves you cost because you don't have to pay for that retrieval from S3 again. So this next one is probably one of the most common things that I see, especially customers who have been using AWS for a while, which is you're coming from a file system, you have a naming convention. A naming convention is account name or number plus a date, and the date increments by 1, and the next one, and the next one, and the next one. So what happens? Well, in a file system, that's cool, it really doesn't matter. And S3 matters a lot. Because what we have is essentially, when I talked about the parallelization under the covers, what we do is we essentially segment out the data in partitions, right? And so what happens is if you have, now we've talked about the front end, we're getting into the innards now of S3 a little bit. If you do this, what will happen is you will again focus all of the energy on one partition or one part of what we call the index of S3. And what happens then is you're going to say, oh, S3 isn't performing. I'm only getting X, hundreds of transactions per second, or TPS. Wow, S3 really sucks, right? So and again, back to parallelization as your friend, and in using scale, what you're doing is you're hitting essentially a hotspot or touching one area of this massive infrastructure. You're not taking advantage of that scale. So what we recommend is the opposite. Basically create as much randomness as you can in that file name, in that prefix, especially at the beginning of it. It's just 4 or 5 characters actually will create enough entropy. And what that will allow you to do is basically spread across the S3 index infrastructure, across those, to allow basically that to be serviced by a number of areas within the index, so you're not creating a hotspot. And so this is probably one of the more common, when you think about it, and it's really important for this audience, so think about it when you're architecting up front. Because if you do this, and this is all your file names like this, and then you call and say, well, geez, we're only getting X amount of, and we're getting, of throughput, it's really hard sometimes to go from this back to this. But if you're architecting up front, and say you're doing a file server migration or architecting a new application up front, it's very simple to create some entropy and kind of create a conversion table, say, between, or just flip it around with a reverse timestamp to do that in the logic. Harder to do later to comb through perhaps billions of objects. Really important to do it and think about it up front. So summarizing performance, there's a lot more, but these are some of the basic ones. We talked about uploading and downloading, optimizing with range gets. We talked about distributing the key names. And then we didn't talk about SQL query on S3 with Athena. That's another capability that we have introduced. So basically what you can do is dump all of your data in its native format and be able to do SQL queries directly on the data within S3 without moving it. So that's another kind of performance. I wouldn't call it performance as much as kind of a cost savings and time savings of having to move the data around into because you can do the query of the data where it resides. And then for networking, there's some networking and there's some good best practices that are out there, but especially with mobile applications, any of you that are developing mobile applications, it's good to use the TCP stack for the fast lossy connections. And then we have really long, fat networks. You just make the window size. Those are just, those of you in networking, you know these things, but it's just common things where you want to be able to improve, and these package things together. I'd say the two things out of this whole list to remember are use the multipart upload and use the proper prefix design. Those two things will save your life and improve your performance as you're deploying on S3. So we talked about performance, we talked about automation. Now what about tools to manage your storage? So we talked a little bit about lifecycle management and data analytics, but we introduced a whole set of new visibility and management capabilities at the last reInvent. One of those is object tags. And when I heard about object tags, I was saying, well, this is cool and interesting. But as I started talking to customers, it becomes really cool and interesting. Because if you think about your data, what you had before were, let's call it, sticks and rocks and good crude tools to categorize your data. You had prefixes, and you had buckets within S3. With object tags, and specifically what we introduced are mutable object-level tags, up to 10 per object, that now allow you really almost an indefinite way to categorize your data. So example one, you have highly compliant data, and you only want a certain set of internal constituents to take to access that data. Well, you tag it as highly classified or highly compliant, and what you can do is take that tag, and you can either write the tag at time of object creation or any time after object creation. And that's a big difference with these object-level tags. Before S3, you write the data. If you want to change the data, you actually can't. You have to copy and rewrite that data. So that's one thing. Now, if you want to, say, write an object, later write a tag, and then update that tag later, you can do that with this mutable object tag. So it's a lot of flexibility. What it allows you to do now is really a couple things. One is access control. So as I said, you've got one constituency. You can take a security policy and say, I only want, with our IAM policy, this set of internal constituents to access this data, nobody else. So it interfaces with our IAM. Secondly, lifecycle. We talked about lifecycle. You can say, great, all this really super hot data, big data, I don't want this accidentally to be moved after 30 days into S3 or Glacier, because I'm going to be pulling it back. So this is always going to stay here in S3. So you can apply a tag that says hot and keep hot forever in S3, or don't even have a lifecycle policy. And the third is storage metrics and analytics. So we talked a little bit, and I'll talk a little bit more, but before you could do our analytics and metrics based on prefix or bucket, now you can do it on tag as well. So now you can also, for reporting, you can say, many of you I know probably are internal service organizations to other organizations. You might have 10, 50, 100, 1,000 organizations. What you can do is tag now these objects and then very easily run reports and have metrics by these tags at a much higher level of granularity than you were able to do before with just buckets or prefixes. So that's tagging. And here's an example of setting user permissions, for example, by tag. So you can say, for example, resource, example bucket name here, and allow this particular tag and allow that particular tag to be able to access that object. You can also, another policy is the opposite of access. It's, and a lot of what I hear from especially financial institutions and regulated industries is I really want to ensure that objects don't get deleted. And certainly so there are a number of different best practices to do that. One of the most common things that we recommend is versioning, because what happens if you version it and somebody deletes it, you can always get it back. And then we have a solution called MFA, multi-factor authentication delete, right? So versioning combined with MFA delete, which means that you have to have a device, and that device has a number on it, and you have to match the number to be able to delete the object. Those two things together provides a very high level of certainty that any random user isn't going to maliciously or non-maliciously delete the data. So a best practice, especially I talk to a lot of financial institutions who want to make sure that the data is there. Also, a lot of government institutions have a compliance requirement to prove, and so on, policies in place to prevent deletion or modification. So this is a good best practice to think about as you're deploying in S3. So the other piece of compliance is, okay, every time I touch an object or manipulate an object, we want to be able to monitor that. So we also introduced this AWS Cloud Trail events that basically create a trail and that then of every single activity performed at a per object level. So object level requests enabled at the bucket level, and then logs of that data. So now you, in addition to preventing deletion, right, if you decided that for some reason you didn't want to do that and somebody did delete an object, you would have an audit trail of that. But more importantly, you also have an audit trail of anybody that's touched an object, accessed an object, et cetera. So very important for some customers. So we talked about visibility, monitoring metrics, and so on. The types of cloud trails for compliance. But one of the things that I also heard from customers was, hey, all of a sudden I'm getting a latency spike, or hey, I'm getting throttled. Well, what's going on with S3? And it was a black box. So what we introduced was we have a solution called CloudWatch, and we introduced a whole slew of S3 metrics that allow you at a very granular level to understand what's going on. So how many requests, how many GET requests, different types of head, post requests, et cetera, all the requests that we're able to, and how many of those over X period of time. Bytes downloaded, and then the ones that are really interesting are the throttling and latency. And here's an example of, for example, that total request latency modeled over time. So you can generate reports of these CloudWatch metrics as well, or export them. So again, providing a lot of visibility. To add to visibility, how many of you have more than, say, 1 million objects today in S3 that you can share? So okay, don't mention who you are. So, so if you want to do a list on those, which is a listing of all the objects in a particular bucket, that can take a long time when you get into millions or billions or trillions of objects, as some of our customers have. So what they said is, we'd love to be able to do this, but we'd like to get it back within a day or a week or a month, right, and not continuously run it. So what S3 inventory does is take the power of S3 in the background, create an inventory of a particular bucket, and deliver either a daily or a weekly report for customers who have many, many, many objects. So it's a really cool capability, because then you can perform different, kind of deltas, different actions and everything on objects that have changed, and it allows you it's a lot less lift for you. And if you do the math, especially with billions of objects or even millions of objects, it's actually a lot less expensive to do an inventory versus a list. So to kind of pull it all together, we had a company called Alert Logic. They're in the security monitoring space, commercial, and they have a SaaS solution that runs on AWS. They migrated from, they already had some data on AWS, but they migrated off their filer, their on-premise NAS solution. And it was multiple petabytes. And they're growing at a couple petabytes per month, 4,000 customers. And what they wanted to do is migrate off their file system, but they wanted to be able to take advantage of all the capabilities of S3. So they needed to use the proper prefix design, which was the randomness in the keys. So the problem was, then they couldn't use lifecycle management. Because if lifecycle management, say, matches on the prefix, and the prefix is random, how do you actually move different objects into different tiers if you can't match it because it's completely random? So they use tagging to basically tag each one of their 4,000 customers and attribute it. And now they can use lifecycle management, gain performance. They're using cross-region replication, and they're tiering off to Glacier, and then retrieving it with our retrieval tiers. I kid you not, like we came out with these features, and they used every single one day one. So again, they're a really great customer, really great partner, but it really exemplifies how you can pull all these different things together to use all the different capabilities that we just talked about. So the final thing is, we talked about how to manage it. How do you get it in the first place, right? So data has a lot of gravity, as we talked about. 100 petabytes over a 1 gigabit per second direct connect, 27 years. I'd be dead by then. So actually, I'd be more dead over the 100 petabytes. I don't know if you can be more or less dead. I guess they could prop me up, and I could somehow, yeah. So moving the data into S3, we have a lot of different, again, online and batch capabilities to do that. And if you have, say, in the more than 10 petabyte range, we introduced AWS Snowmobile. So for customers that, let me just give you a couple examples in the remaining minutes. Say you have multiple locations and you're constantly online uploading lots of data. We have something called S3 transfer acceleration. Rather than going over the internet, you can basically upload it to a local POP. We have, I think it's up to over 70 edge locations now globally. We'll find through our Route 53 DNS service the local one to you, say you're in Singapore, and instead of moving the data all the way through and over the internet to S3, it's going to upload it locally and then use our high-speed backbone to get there. So this can generate efficiencies ranging from not a lot if you're in Singapore to a lot if you're going to the other side of the world. Takeaway here is highly latent connections, lots of people uploading lots of files to one central location. S3 transfer acceleration can help a lot. So Snowball, I think you've seen it. Very simple. Go into your console, connect the Snowball, copy the data to Snowball securely, and then it's with your own keys. Your data is moved and appears in S3. We introduced Snowball Edge, which takes that data shuttle concept and improves it by adding compute and a little additional capacity. So we had a 50 terabyte Snowball when we started. We improved that to 80 terabytes, and then the new Snowball Edge is 100 terabytes, plus also the compute equivalent of an EC2 MX4 XL instance. So what this does, if you think about the general kind of how Snowball was used before in the data shuttling environment, now what you can do is collect data, process the data locally, and then actually do some local pre-processing of the data, and then add that, if you will, to the data shuttle opportunity. So Oregon State University is a great example. So anybody here, which probably is many of you, that has mobile kind of disconnected or really poor connectivity, you can take the data like Oregon State University did, do local analysis on their ships, and then basically when you come back and you have better connectivity, move that into S3 and AWS. So Storage Gateway is our last solution. I want to talk about bridging the gap. Basically, if you have older applications or even new applications that you can't re-architect for the cloud, S3 native, we have 3 modes. This is a virtual machine that runs on-premise. It presents either an NFS interface, an iSCSI mount point, or a iSCSI interface, or a VTL, meaning it can look like a tape device. So what we do is you can write to that on-premise, and then it translates that and moves that data into S3 and can tier that to Glacier. Moderna Pharmaceuticals is using the file mode, and this is the coolest new mode that we have, because what you can do is write a file locally on-premise. They have lab equipment, and it translates the output of that lab equipment directly into an S3 object on the other side, and then they can process that data, say, with analytics tools. That's one of the only solutions out there. The takeaway from this is if you want to keep your data and you want to kick off a process and analyze that data in the cloud, the Storage Gateway file mode is one of the only solutions, ours or any third party, that will allow you to do that and maintain that object transparency. VTL is another mode. So this, again, just plugs in. Anybody have tape? Anybody do backup here? OK, so plug and play, looks like a tape device, and we can basically back up. What Southern Oregon University did was allow you to back up to the cloud, but also had a DR scenario in that they actually, and the data not only was uploaded to S3, it was uploaded to an S3 bucket on the other side of the country. So they get DR and backup in one shot. So finally, if we can't do it, there are third parties that can help you get data in. So whether it's primary storage, meaning tiering, backup recovery, or archive, we have many, many, many storage solutions. We just launched a new storage competency, so that gives you a little, both for systems integrators partners as well as third-party ISVs that give you trust and quality that they've been vetted by AWS. So thank you. I know I went about a minute over. Hopefully you learned one thing. Appreciate the time.